everyone, welcome back to my YouTube channel. In this video, we shall discuss on the equilibrium constant, so let's get started. Determine the equilibrium constant for the reaction between nitrogen monoxide and oxygen that takes place in a sealed container and reaches equilibrium under specific condition. Initially, 0.5 molar of nitrogen monoxide and 0.250 molar of oxygen are present with no nitrogen dioxide. After equilibrium is established, the concentration of nitrogen dioxide is measured to be 0.4 molar. We shall start answering this question by writing the balance equation for the reaction. So we have the reaction between nitrogen monoxide with oxygen to produce nitrogen dioxide. So the next thing we need to do is we need to balance out this equation. So in this question, we already have 3 oxygen at the reactant and only 2 oxygen at the product. Therefore, the easiest way is we put 2 here so that we can have 4 oxygen altogether. So in order for us to have 4 oxygen, we need to add 2 in front here. So we are going to check on the nitrogen. We have 2 nitrogen at the reactant, also at the product. So the next thing that we need to do is we need to write the ICE diagram. So the ICE diagram, initial change and equilibrium. So initially it states that it have 0.5 molar nitrogen monoxide. So here 0.5. You do not have to change anything because it's already in molarity, and it have 0.25 molar of oxygen. So I'm just going to remove the molar here. Right, but there's no NO2 being formed at the beginning. So same goes at change. This one will be 2x, this one will be negative x, and this one will be positive 2x. So at the end, it's going to be 0.5 minus 2x. So 0.25 minus x and 2x. Therefore, when you want to calculate, you're going to do the Kc, which is NO2 to the power of 2 divided by NO to the power of 2 times O2. Right. So if we look back at the question, it states here that at equilibrium, the concentration of nitrogen dioxide is equivalent to 0.4. Therefore, 2x is actually equivalent to 0.4. Therefore, your x is equivalent to 0.4 divided by 2, which is 0.2. So what we can do now is we are going to substitute all the x's with 0.2. Alright, so after the substitution, we will get the NO will be equivalent to 0.1. This one will be 0.05 and this one will be 0.4. So what we can do now is we can use all this value to find what is the value of your Kc. Right, so now we are going to find what is the value of Kc. So Kc is equivalent to whatever in the product, which is NO2 to the power of 2 divided by whatever in the reactant, which is NO to the power of 2 times O2. Right? So we are just going to plug in the value 0.4 to the power of 2 divided by 0.1 to the power of 2 times 0.05. Therefore, you will get your Kc should be equivalent to 1.6 times 10 to the power of negative 1 divided by 5.0 times 10 to the power of negative 4. Therefore, your Kc should be equivalent to 320. So this is the final answer for this question. Thank you so much for watching this video from the beginning till the end. So I'll see you again in the next video. Goodbye.